Why are there not more people talking about the expanding universe? Today, we're embarking on a journey to explore one of the most awe-inspiring and mind-bending concepts in cosmology, the expanding universe. Imagine the vastness of space, not just as something static, but as a living, breathing entity that's continuously growing, stretching, and evolving. From the moment the universe burst into existence to the distant future, when stars may flicker out, our universe has been on an incredible journey, and we're here to explore it all. We'll start with the groundbreaking observations of Edwin Hubble, dive into the Big Bang that sparked everything we see today, and venture into the unknown, contemplating the possible fates awaiting the cosmos. Buckle up, because this is going to be a cosmic ride unlike any other. Ready to dive deep into the mysteries of space? Let's go. Our journey begins with a revolutionary idea that changed how we see the cosmos: Hubble's law. Imagine it's the 1920s, a time when scientists believed the universe was static, unchanging. Then came Edwin Hubble, an astronomer who looked deeper into space than anyone had before. What he found shattered centuries of belief. Galaxies far from Earth are moving away from us, and the farther they are, the faster they're receding. This was the first clue that our universe is not static. It's expanding. Hubble's discovery didn't just happen overnight. He meticulously observed galaxies and noticed something peculiar. The light coming from them was shifting toward the red end of the spectrum. This redshift occurs when light waves are stretched as an object moves away, similar to the Doppler effect we experience with sound when an ambulance passes by. But why is this redshift important? It's evidence that the universe itself is stretching, causing the galaxies to move apart. And here's where it gets even more exciting. The faster the galaxies are moving away, the greater the redshift. This gave rise to the now famous Hubble constant, a number that helps astronomers estimate the rate of expansion and even the age of the universe. With current calculations, the universe is about 13.8 billion years old. Just think about that, 13.8 billion years of cosmic history, with all the stars, galaxies, and life that has formed along the way. But here's a twist: recent observations, including data from the James Webb Space Telescope, suggest that there might be inconsistencies in the Hubble constant, sparking debates among scientists. Could it be that the universe's expansion is more complex than we thought? Stay tuned, because the mystery of our expanding universe is far from settled. Now, let's hit rewind, way back. Imagine a time when everything, every star, planet, and galaxy, was compressed into a point so small it defies imagination. This brings us to the Big Bang Theory, the moment that ignited the birth of the universe. Around 13.8 billion years ago, the universe as we know it exploded into existence from an incredibly hot, dense point known as the initial singularity. There was no space, no time, just an unimaginably intense burst of energy. As the universe expanded, it began to cool. Within minutes, the first atomic particles formed, leading to the creation of the first simple atoms, like hydrogen and helium. These atoms eventually clumped together to form the first stars and galaxies. But how do we know all this? The answer lies in the cosmic microwave background, CMB. A faint glow of radiation that fills the universe and gives us a glimpse into what it looked like just 380,000 years after the Big Bang. Think of the CMB as a snapshot of the universe's baby pictures. By studying this afterglow, scientists have been able to confirm many predictions of the Big Bang Theory, like the universe's expansion and its early conditions. Yet, the Big Bang wasn't a literal explosion in space. It was an expansion of space itself. Even today, the universe is still stretching in all directions. And here's something to ponder. This expansion is speeding up, thanks to a mysterious force called dark energy. What is dark energy? We don't know for sure, but it makes up about 68% of the universe, and its effects are accelerating the universe's expansion, pushing galaxies farther and farther apart. Isn't it fascinating to think that every atom in your body once existed in the early universe, formed by the same cosmic forces that shaped the stars? So where is all this expansion leading? The universe is growing, but how will it all end? Scientists have several theories, and each one is as captivating as the last. One of the most widely accepted ideas is the Big Freeze, also known as the heat death. In this scenario, the universe will continue expanding indefinitely. Over time, galaxies will drift so far apart that they will become invisible to one another. Stars will burn through their fuel, leaving behind cold remnants like white dwarfs and neutron stars. As the universe stretches, it will cool down, eventually reaching a state of near absolute zero. Picture a cold, dark cosmos, where not even light can escape the cold grasp of time. But there's another possibility: the Big Crunch. If the universe's density is high enough, gravity might slow the expansion and eventually reverse it. In this scenario, the universe would stop expanding and begin to contract, pulling galaxies, stars, and planets back together. Everything would collapse back into a hot, dense state, much like the conditions of the Big Bang. Could this lead to a new Big Bang? Some scientists believe this might result in a cyclical universe, where a new universe could be born from the ashes of the old one. And then, there's the most dramatic end of all, the Big Rip. If dark energy continues to drive the universe's expansion at an accelerating rate, there's a possibility that eventually, the force will become so strong it will tear apart galaxies, stars, planets, and even atoms. The universe would be ripped to pieces, leaving nothing but a chaotic expanse of particles. But here's the exciting part. While we have these fascinating theories, no one knows for sure how the universe will end. The cosmos still holds countless secrets, and every new discovery brings us one step closer to understanding its grand fate. Will it freeze, crunch, or rip? The adventure of discovery continues. From Hubble's revelation of an expanding universe to the fiery beginnings of the Big Bang and the mind-boggling futures that may await us, the story of our cosmos is far from over. Every new discovery, every new piece of data, is like another chapter in the greatest story ever told, one that stretches across billions of years, from the birth of stars to the future of galaxies. If today's journey through space has ignited your curiosity, make sure to hit that like button, subscribe, and tap the notification bell for more thrilling cosmic content. The universe is vast and full of wonders, and there's so much more for us to uncover. Until next time, keep your eyes on the stars and stay endlessly curious about the universe around us. What mysteries will we uncover next? Stay cosmic.